Howdy PreCal, it is Ms. Kosh. This is the last of the conic sections that we need to do, and this is the parabola. So with the parabola, we've taken our cone and we've kind of sliced it at an angle where we get just this, this one little piece. A parabola is created by slicing a double naked cone by a plane going through the base of a single cone. A parabola is a set, the parabola is a set of all points equidistant from a line called the directrix and a point called the focus. Okay, so what happens here is in our parabola, did I draw one? Oh, I should have included one. That would have been nice. In our parabola, it's gonna open up, down, left, right. We have a point inside here and a line out here. So here's the focus, here's the directrix, and then any point on the parabola, this distance and then this distance it's perpendicular, those are always the same if I drew it properly. I may not have drawn it properly. Okay, so that's how they're defined in terms of distance. There we go. This one, okay, so if x is squared, it's going to open up, I wanted to write up or down. If the y is squared, it's going to open left or right. Not both, but depends on if it's positive or negative. The vertex is HK. The vertex here is also HK. The focus, okay, so what we do when we go to graph this is we find the vertex, wherever the vertex is, and then we, whatever. Here's our vertex, let's say, and it's opening up. So we will come, we put in our vertex, and then we would move p units one way and p units the other way. And so to get this, if this is the point hk, then we're going to have the same x value h, and then we're going to have k plus p to get the focus. And we're going to come down, this is the line y equals k minus p. Okay, if p was negative, then it's going to open the opposite way. And so the focus is the point h comma k plus p. This is almost easier to do once we actually have numbers. The directrix is that line, and in this case it's going to be y is equal to k minus p. The LR, so there's this thing, they call it the lattice rectum, which always makes everybody giggle. It's a segment that goes through the focus and would go to one end of the parabola to the other end. And that whole distance here is 4p. So the length is 4p. The axis of symmetry here would be coming through the middle of our graph. And so this is going to be x is equal to, what's the x value? H. Okay, so the other one is going to open left or right, depending on, we can manipulate this formula to get to that, and you can kind of use either one. This is going to open left or right. It's going to be kind of more like this. Here's our vertex, which is HK. And then once again, our focus is going to be, well, it's going to be H plus P and K. And then our directrix, which I should have saved space for, is going to be this line x equals H minus P. So I have somebody at the door and I'm ignoring them. Let's see if they go away. H plus P comma K. And then the directrix is going to be x equals H minus P. Okay, the LR still has a length of 4p. And the axis of symmetry now is going to be y equals, well, what's that y value? It's that y value is equal to k. Okay, let's go try one. Okay, so on this one, I have a vertex. My x coordinate is 1. My y coordinate is going to be -3. This is going to open, so this, my p value, this is that 4p, so my p value is equal to -2. Since the x is squared, this is going to open up or down. Since p is negative, it's going to open down. Okay, so we can start by plugging in, or by plotting that point, 1, -3, 1, 2, 3. And then we're going to, 2 units away, 1, 2 is going to be the focus. 2 units, 1, 2 is going to be the line of the directrix. Okay, so the axis of symmetry, this is opening down, the axis, well, hang on, let's just keep going. The focus, that will be 2 down from here, so this is 1, -5. The LR has a length of 4 times this, so it's the absolute value. I forgot to say that. Let's come back over here. The LR is the absolute value of 4p. Okay. So 2 times that is, or excuse me, 4 times that is 8, so the LR has a length of 8 units. So we're going to come from this focus and go 1, hang on. We're going to go 1, 2, 3, 4. We're going to go 1, 2, 3, 4 units there. Our directrix was, we said the line y equals -1. Our axis of symmetry is going through this way. It's going to be x equals 1. And make sure you tell me x equals and y equals. If you don't, you're wrong. And so our graph goes something like this. Our domain is going to be -infinity to +infinity. Our range goes from -infinity. How high did this go? That was had a y value of -3, and we do want to use a hard bracket. Okay, let's look at the next one and see what happens. Okay, so the vertex, the x coordinate is 3, the y coordinate is -2. This one, my p value comes, this is 4p, so p would equal 4. And so this is the y is squared, so it's going to open left or right. Since it's positive, it's going to open to the right. So I'm going to graph this point 3, 1, 2, 3, -2. Here's my vertex. My focus is going to be 4 units away. 1, 2, 3, 4. And then my directrix, 1, 2, 3, 4, is going to be this line here. Okay. Axis of symmetry would be y equals whatever that y coordinate is, y equals -2. The focus, we just said we were at 3 and then we added 4 more. So 7, -2. My LR is 4 times that is 16 units long. So from here I have to go down 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay, at least we're still on there. 1, 2, 3, 4, 5, 6, 7, 8. And so here is, okay, the shape of my parabola. Directrix was the line x equals -1. If you don't tell me x and y, I'm not going to give you credit. The domain is going to start here at this x value of 3, 1, 2, 3, to infinity. The range is all reals. Let's see, I have a couple more problems. Maybe I'll come back, do some completing the square in the next video. Just maybe I can go check and see who was at my door, see if they're still there. Okay, so like, subscribe, comment, and the only way to learn math is to practice. So go practice and then come back for the last video. Goodbye.